Alright, today I'm going to be going over the SBAC Practice questions 4. Write the expression equivalent to the following using the fewest number of possible terms. So first thing I see when I look at question number 1 is a negative here, and I know that I'm going to have to distribute that negative. Then I see another negative here, and I know I'm going to have to distribute that. So I'm going to get r cubed plus 2r squared plus 4 minus 2r cubed plus r to the 4th, because I'm distributing that negative. Distributing this one, I'm going to get negative 8r squared plus 4r to the 4th. And now it says with the fewest possible terms, which means I need to combine like terms. So I'm going to look for the highest degree first, and I'm going to see that that's r to the 4th and r to the 4th. So r to the 4th and 4r to the 4th gives me 5r to the 4th. Then if I look for the next, I would have cubes. So I see a cube here and a cube here. So r cubed minus 2r cubed is minus r cubed. Then I would have my squared term, so I have 2r squared minus 8r squared. So 2 minus 8 is negative 6r squared. And last but not least, I have plus 4. For question number 2, same thing. I have 8 plus 6x minus 2x cubed. I need to distribute this negative here, and I get negative 5 minus 6x cubed. And I need to distribute this negative, so I get negative x cubed minus 7. Now if I combine like terms, my highest exponent I see is a cube. So I have a cube term here, a cube term here, and a cube term here. So negative 2 minus 6 is negative 8, minus 1 is a negative 9x cubed. Let's see, I have no x squared terms, so the next one I have is just an x term. And there's nothing to combine it with, so I just have that. And then I have an 8, a negative 5, and a negative 7, and I can combine all those. 8 minus 5 is 3, minus 7 is negative 4. And there is my, oh, I just realized I made a mistake on number 1. This should have been a 3, because it was my cube terms that I combined to get that. So those are my equivalent expressions written with the fewest number possible terms. For number 3, it says determine whether each question is true for all values of x. Select yes or no. So is it true that 5 to the power of 3x is equal to 3 to the power of 5x? Well, it says for all values of x. So if you can find any value that this isn't true, then you know it's not. So let's see, 5 to the power of 3x. Let's say x was 1, and plug in 1 to both of these. 5 to the 3rd power is 125, and 3 to the 5th power, let me actually figure out what that is. That's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, and then times 3, which is 243. So does 125 equal 243? No. Okay, for this one here, if I plug in 1, I'd get 2 to the power of 3, which is 8, and 8 to the power of 1, which is 8. But is it always true? So I'm going to think about this. 2 to the power of 3 to the power of x is how I could rewrite that, equals 8 to the power of x. So is 2 to the power of 3 8? Yeah, so I get 8 to the power of x equals 8 to the power of x. So yes, this is true. If I had done that same thing here, for this top one, I would have had 125 to the power of x equals 243 to the power of x, which is not true for all values, so no. For this one here, I have 27 to the power of x equals, what's 3 cubed? 3 to the power of 3 is 27, x. So is that true? Yeah. If I plug in 1 here and 1 here, yeah. Plug in 3 here and 3 here, yeah. Plug in 500 and 500, yeah. This is true for all values. Here, 5 to the power of 4x. Now, on quick glance, some people will be like, oh yeah, that's 20 to the power of x equals 20 to the power of x. But you have to realize that's 5 to the power of 4. 5 to the power of 4 is 5 times 5 times 5 times 5. And that to the power of x. So 625 to the power of x equals 20 to the power of x? No. Okay. Question number 4. Use the equation below to answer the question. So, which equivalent equation is correctly matched with a key feature of the graph of the function it represents? So it looks like they have FOILed this out or multiplied this out. So x times x is x squared, x times 1 is 1x, negative 6 times x is negative 6x, and negative 6 times 1 is negative 6, and they got x squared x squared minus 5x minus 6. So what does this highlight here? So does it highlight that there's an x-intercept at negative 5? Does it highlight that there's an x-intercept at negative 6? Does it highlight that there's a y-intercept at negative 5? And does it highlight that there's a y-intercept at negative 6? So first of all, I think x-intercept, I think y equals 0. If I plug in y equals 0, remember f of x is just another fancy way of saying y. So if I plug in y equals 0 here, does that really highlight that there's an x-intercept? I don't really see it, but let's continue and see if we see it from here. For y-intercept, I think about plugging in x to be 0. Plugging in x to be 0. Oh, this x to be 0. 5 times 0 is 0. 5 times 0 is 0. So here, if I plug in x to be 0, I get negative 6. So to me, I see that this format, or the way of writing this, highlights easily that if this was 0 and this was 0, I've got a y-intercept at negative 6, not negative 5. So it's not that one. We didn't get our x-intercepts from that, so we know that the answer choice is D. For number 5, which equation reveals the minimum or maximum value without changing the form? So without manipulating this, can you find your minimum or maximum of this? So the first thing I think about is what's the minimum or maximum point of this graph? So I see that it's a quadratic. In fact, I see that all of these are quadratics. That's x squared, that's x squared, that's x squared. This, if I were to FOIL it out, x times x would give me x squared. So remember, a parabola either looks like this with the maximum point there, or this with a minimum point here. And that fancy term for that point is the vertex. So which one of these highlight the vertex? If you recall, it's this form where our vertex is h comma k. So h here is negative 2. You flip the sign of what's in here, and you keep the sign of k. So that's a negative 1. So without changing the form, I can easily see that my formula here, this vertex form is what it's called, can give me my maximum or minimum point. So B. Alright, for number 6, select the expression that is equivalent. I could take the time and FOIL all of these out and see which one gives me an equivalent statement, or you can remember difference of squares. And this is a perfect square, so I'd have 5k and 5k. And this is a perfect square, so I'd have 2 and 2. And since there's no middle term, I need it to add to 0, so one's negative and one's positive. And if I look, that matches with answer choice C. Same thing can be done for number 7, so I'm going to move on to number 8. Now, number 8, some of you guys would say, oh, distribute this, and I would get D. You cannot distribute this because of the square here. This is n plus 1 squared. So remember that n plus 1 squared is actually n plus 1 times n plus 1. Okay, so now I can distribute this, and I could get 3n plus 3 times n plus 1. And now I FOIL this, and I get 3n squared plus 3n plus 3n, what is that, plus 3. So 3n squared plus 6n plus 3. So I see that it actually matches with B. Okay, same type of thing here. Remember, 2x plus 4 is 2x plus 4 times 2x plus 4. You can't distribute the exponent, not when there's a plus inside. That plus is, nope, can't do that. And you can't distribute that 3. You actually have to FOIL this out. Alright, number 10. Number 10 has an exponent on the outside and no addition or subtraction in here, so we can and should distribute this. So 2 to the power 4, y to the power 4, and x to the power 4 times 4 is x to the power of 16. Taking this a little step further, this 2 to the 4th is 16. So I have this expression here, which actually matches with answer choice C. Same thing on number 11, distribute that exponent and finish that question. Okay, number 12. Number 12, I have n to the 4th over n, and you can think about this as 4 n's over 1 n, and these reduce, and I get n to the 3rd. Or, in like number 13, I might use my exponent properties, and when I have the same base, that's b to the power of 8 divided by b to the power of 3, so the base is b. I have b 8 minus 3. I can use quotient property and subtract those exponents and get b to the power of 5. Okay, b to the power of 5 is on top because we had 8 minus 3 is 5. If it was a negative 5, let's say I had b, let's say b to the 3rd over b to the 8th, that would be different. That would be a negative 5. 3 minus 8 is negative 5, and then that would end up being that. But that's not what we had. We had this up here. Alright, number 14, last question. Select the zeros of the function. So if I'm looking at this, what do the zeros mean? The zeros are when you plug in y to be 0, or the roots, if you will. So we're looking for, where does y equal 0? Y equals 0 here, and specifically on this graph here. So what is my 0 of this function? Well, it's when x equals 4. Okay, the zeros, another word for that, which you guys are probably more common, or find more common, is the x-intercepts. Alright, happy studying, guys.